Welcome back to Chem Reactor. In today's video, we're going to discuss a very important reagent in organic synthesis, N N Carbonyldiimidazole or CDI, its synthetic applications. Either you're a medicinal chemist or a process chemist, you may have already used this reagent or you may be using this in the future. CDI is a white crystalline powder. Because of its unique ability to activate carboxylic acids and other functional groups under relatively mild conditions as compared to the other coupling reagents, that makes it a useful reagent in multiple synthetic transformations. Plus, its unique ability to produce a clean byproducts. Before going to the synthetic applications of the CDI, first we will see the reaction mechanism, how this coupling reagent works in multiple synthetic transformations. So for that, I have taken here amide bond formation as an example. In the first step, CDI deprotonates carboxylic acid that forms this carboxylate anion. In the next step, carboxylate anion adds to this protonated CDI, and then that forms this mixed anhydride intermediate. In the next step, this mixed anhydride intermediate gets converted to this acyl imidazole. Finally, amine reacts with this acyl imidazole intermediate that forms this amide bond. Now let's break down the synthetic applications of the CDI and why it is essential tool for the chemist. First up, amide bond formation. CDI activates carboxylic acid into acyl imidazole intermediate. In the next step, amine reacts with this intermediate acyl imidazole intermediate, and that produces this amine bond or amide products. This is a very important reaction in peptide synthesis as well as in amide containing pharmaceuticals as well as the synthesis of natural products. CDI enables these reactions without requiring any harsh activating reagents, making it both efficient and very selective for the synthesis. Next, esterification. Esterification works in a similar way like amide bond formation. Here, esterification using a CDI is applied in many syntheses of prodrugs, fine chemicals as well as various natural products. Here it's the same. CDI activates carboxylic acid into acyl imidazole intermediate, and then alcohol reacts with this acyl imidazole intermediate that forms this ester as a product. Next, carbamate synthesis. These carbamates are significant in medicinal chemistry and in the production of agrochemicals, as well as these carbamates are key structural units in many bioactive molecules. So here this carbamate can also synthesize by using the CDI. CDI reacts with this alcohol and then that forms this intermediate, and in the next step amine reacts with this intermediate that forms this carbamate as a product. Another interesting application of CDI is anhydride formation. We can synthesize symmetrical or unsymmetrical anhydrides from carboxylic acid by using a CDI as a coupling reagent. Now let's talk about the urea formation. CDI can react with two equivalents of amines to form symmetrical or unsymmetrical ureas, which are valuable in medicinal chemistry. Depending on our requirement, we can make symmetrical or unsymmetrical ureas. Another coolest application of CDI is the cyclization reaction. This CDI promotes intermolecular cyclization, forming imidazole intermediate that subsequently undergoes ring closure that forms this cyclized heterocyclic compounds. Finally, CDI is a fantastic nucleophile activating reagent. CDI can activate many nucleophiles like alcohols into a reactive species. This activation is really essential in various substitution and coupling reactions, like for example here the synthesis of this CN bond. This nucleophile activation property is exploited in diverse synthetic routes, including the construction of heterocycles and other complex molecular architectures. So why CDI is such a valuable reagent in organic synthesis? Because it is a safer alternative to phosgene. It eliminates the need of additional bases, since imidazole as a byproduct that acts as a base in many synthetic reactions. And also it is compatible with a wide range of nucleophiles and reaction conditions. In summary, CDI is a very useful reagent in multiple functional group transformations like the synthesis of amides from acid and amine, as well as esters, carbamates and anhydride formation. Along with this, we can also make ureas from the CDI, as well as heterocycles like diketopiperazine, and then the substitution reactions of the nucleophiles. I hope you enjoyed the video, and please don't forget to like the video and subscribe to the channel, and yes, don't forget to press the bell icon for updates. See you in the next video. Bye.